Hello, my name is Sarah Thompson. Today I'll be talking about the addition and subtraction of decimals at the 5th grade age level. 5th graders are required by standards to understand how to add and subtract fractions fluently. In addition to that, they need to have a firm understanding of how to divide and multiply fractions. Another standard they must do is understand how to add and subtract decimals into the 100th place value. With this, they need to know how to add and subtract decimals with and without whole numbers. And then another standard they must know is the volume, understanding of volume. And so those are just the standards in the math area that 5th grade students must know. When teaching students in the 5th grade age level about decimals, they have some misconceptions. And some of those misconceptions are that the larger the number looks, as far as the more numbers there are, such as 2.156, they think that this number is larger than the number of 2.2 because there's just more numbers involved, which indeed is not the case. We need to teach the students that the place value of the tenths, hundredths, and thousandths is a big deal in trying to decipher which number is larger. They also have the misunderstanding of numbers in the reverse way. So they think the number 2.1 is larger than 2.23 just because of the idea of us telling them, okay, well, this number is larger than this, and then they think all numbers with smaller amount of digits is then larger. So that's just something that we need to teach the students, is that place value, we must look in the tenths, hundredths, and thousandths in order to decipher which number is indeed larger. Another problem that students have is the aligning of numbers. So you see you have 27.1 plus 2.34. When working with whole numbers, we teach the students to align in the ones place value and go up, tens, hundreds, thousands, so on and so forth. So they want to go 27.1 plus 2.34, which is right in their mind, but is indeed wrong, because one thing we need to do is have the students align the decimals in order to have all numbers and then correct place values in order so we can add and subtract appropriately. So those are just some misconceptions students have when they're first learning how to work with decimals, whether it's adding, subtracting, whatever it may be. And so those are just a few misconceptions they have. So when teaching 5th graders how to add and subtract decimals, the one thing we need to be sure of when we're teachers is that students have a firm understanding of whole number adding and subtraction. Without having this whole number adding and subtraction down pat and then just have a thorough understanding, students will struggle with the idea of carrying and place values of a decimal point. So we as teachers just need to be aware of that. The way I'd start with teaching students how to add and subtract decimals is just with the idea of whole numbers. So we have 23 plus 34. Okay, students would say 3 plus 4 is 7, and 2 plus 3 is 5. They'd have 57, which is correct. And so then I tell the students, okay, what is 2.3 plus 3.4? Students would then do the same thing. They'd go 7, and this is 5, and they'd carry down the decimal, and they'd say 5.7. So that's correct. This is a standard algorithm for adding decimals, and you can do the same with subtracting decimals. And so then I would say, what's the difference in this situation? And they might have a hard time understanding. So I'd write do a value chart of tens, ones, and then the decimal, and then tenths, and hundredths. So then here and here's a decimal, have these place values. So with this 57, the students could write 5, 7, and then with 5.7, they'd have to write in the ones, there's a decimal, and the 7s. So they can then see very clearly that 5.7 is indeed quite a bit smaller than 57. So that's just one way of the standard algorithm that students can learn how to add and subtract decimals. Now, along with the standard algorithm, there is other ways that we can teach students how to add and subtract decimals. These ways are base 10, for instance. So you have 2.12 plus 0.44. So in this situation, base 10, any of the ones would be a cube. So here's ones, and then there's a decimal, and then this is a rod, which is the tenths. I guess I should write tenths. And then a small cube, which is the hundredths. So in this situation, we go 2.1, and then there's the thousandths, 2 thousandths, plus 0.1. So there's 4, and then 4 hundredths. So then we'd add them together. So we have 1, 2, 3, 4, 5, 6. So we draw 6 hundredths. 1, 2, 3, 4, 5. 3, 4, 5. 5 tenths, and then 2 ones. And so then we can then gather this. Here's a decimal. Here's 5. And then here is 6. So that's just with regrouping the two base 10s and getting the number 2.56. So that number, our answer would be 2.56. So the sum of 2.12 plus 0.44 equals 2.56. So that's the addition in base 10 blocks. Now when we look at the subtraction method of base 10 blocks, we can use the numbers like, well, let's do 8.5. Let's actually do 0.65 minus 0.25 equals. So again, here's a decimal. Here's the rod, which is the tenths, and the hundredths with a units cube. So we write it again: 1, 2, 3, 4, 5, 6, and then 5. So then we're subtracting 0.25. So the first thing we do is take 5 hundredths away because we have 5 hundredths. The next thing we do is work to the smaller value, or the next larger value, which is 2, and we take 2 away. Then this shows that we have the remainder of 4, which is 0.4, which is our answer for this problem. Now, another thing that we could do is the idea of a number line. With a number line, we can use 1.5 plus, let's use 2.25. And I'll do the number line from 4, 0, go halfway, this is 2, 1, 3, and then I did quarters in between. So we're going to start with the numbers behind the decimal point because they're a smaller value. So we're going to start at 0.5 and add 0.25. This is just like adding money. And then 1 plus 2 is 3. So we're going to have to go 1, 2, 3. And then we're going to hop all the way over here. And then we can see that we land at 3.75, which is our answer for this problem. There's many ways that we could do this. As again, we could do this with subtracting, and we'd start from the larger number and then work down, starting with the smaller value and then subtract the smaller value, and then subtract the 1's value. There's many ways that you could allow students to think mathematically about this. There's one way, doing math is doing like algorithms, trying to find a problem and finding the right answer. So you're using like an arithmetic method or some sort of method to get to the correct answer. Whereas thinking mathematically is more or less an art. It's trying to open the kids' minds to think something further than beyond what is written in the textbooks or what the traditional way of doing it is. So ways to make students think mathematically is, instead of asking what is the answer to 2.5 plus 1.2, instead of saying what is the answer to this and using a closed-ended question, use an open-ended question saying in what ways or how can I find a way to get from any number, or what numbers can we use to get to the number or the answer of 3.7. So instead of asking a closed-ended question, you ask an open-ended question, which allows the students to think mathematically and try to problem solve in different ways. Me as a teacher, I try to anticipate what the students are thinking and when planning, and this would just help the students think mathematically rather than just doing math. And that's what I hope to be as a teacher, and just allow the students' minds to think above and beyond than what the normal is. Thank you.